Good afternoon. Welcome to Getting Explicit. I'm Dustin Land from id Software. This is a two-part session, starting with my stuff and then ending with a developer panel. There's been some great talks today about the current state of Vulkan in regards to features, challenges, what people are doing. So I wanted to take my time and kind of talk about it at a higher level in terms of the effort involved in making a Vulkan application, how developers are approaching it, and some of the perceptions surrounding that. The comments are funny, but they were actually responses to a blog series I wrote last year on my on porting Doom 3 BFG from OpenGL to Vulkan. They're fairly indicative of the general perceptions of the technology. I'm sure you all have seen comments, uttered comments, or heard them in this regard. And I held some of those perceptions myself until I actually started using the technology. And I found it very, very intuitive, very easy to digest. And so I kind of wanted to come out and share some of my perceptions about the technology as seen through the lens of the port. So a little background about me. I'm actually not, I got my start in web services circa 2005. I landed a full-time contract with id in 2008, and that turned into employment in 2010, working on Quake Live, which was the web-based Quake 3 port. From there, after I got hired on, I helped start an internal team that we call Dev Services. Dev Services builds and maintains various tools and tool chains outside of id Tech that are useful to the studio on a day-to-day basis, such as continuous integration, build distribution, asset management, crash reporting, all sorts of things. Because I was the main integrator of our tools with id Tech, I got more and more work on that side till eventually I just switched teams. Since then I've worked on a whole lot of things from networking, platform code for Sony, for Steam. I've done resource management, large engine refactors, all sorts of things. I'm a generalist, and the studio is kind of happy to oblige me with new challenges all the time, which is great. And I've also been helping support our games at QuakeCon for the last 8 years, so if you go to that event, you may have seen me out there. What I am not a graphics programmer. I've done, over my tenure at id, I may have fixed a renderer once or twice. id likes to hire versatile people that will roll up their sleeves and just fix something if they come across it. I've written a handful of shaders for gameplay, nothing too serious. Like many people in this room, I've played with all the toys that are out there. And like many graphics hopefuls, I've read my fair share of books. I could write a ray tracer in a weekend, but I couldn't argue various trade-offs to different approaches. That's not my forte. There are more capable hands at the studio that do the Lord's work on a day-to-day basis. Tiago, Billy, Axel, Jean. Yep, he's very reclusive. So they've actually given some great talks on the current state of graphics in id Tech recently, especially with Doom 2016. Them and our partner studio, Machine Games out in Sweden, just released Wolfenstein 2 in this last year, and hopefully they'll be able to talk about what they did for that soon. So, Vulkan, this is true. So in 2015 is kind of when we broke the ice with the tech. It wasn't until 2016 that we really got serious and released a Vulkan binary to the wild later that year. There have been clear benefits, and Axel's talked about that previously, so I won't go into the details here. But needless to say, we've solidified our marriage with the technology. The OpenGL renderer is completely gone. This includes, for our tool chain, id Studio is full Vulkan now with multiple swap chains and viewports. And we've been eager for other people to adopt the technology. And I feel like this is kind of where some of those negative perceptions come in. So let's go over those. Hard. That's just like the first word that people say in regards to Vulkan that we've heard. And that's kind of a nebulous term, but I think I know where it comes from, and I'll get to that in a bit in the talk. A lot of code, that's another common one, and I'll also address that directly. Graphics plus. It's like, okay, there's an id guy standing in front of you talking about Vulkan, sure, but I think that's really turned off a lot of hobbyists and beginners from even approaching it. When they're at the digital bookshelf looking, should I get the OpenGL book? Should I get the Vulkan book, DirectX book? I think a lot of them just say, oh, that's for people at the bleeding edge. That's not necessarily for me. If you have a large tech stack, it's kind of considered an expensive investment to refactor your renderer for it. General timelines I've heard are 4 to 6 months, and obviously that's a lot of money. And then unpacking a driver revealed more responsibilities that people have. And so if you don't feel like you're getting any benefit from these new areas, it just feels like more overhead, and that's not necessarily welcome. This was exacerbated by kind of the body of information that was available in the early days. And if I had to kind of delineate that, I'd say the top 10% were expert talks given at events such as these. And then the bottom 20% is introductory, and that's just talking about things in isolation. And that's things that people are hitting on Google, such as Graham Seller's book, the Vulcan tutorial site with its SEO magic. And there's actually some really good, even early on, there were some really good GitHub repos, such as from Sasha Willems regarding all the different features. But really, there wasn't much in the middle, you know, and I think that's where a lot of the pain and frustration kind of came from. And you know, it's kind of the old joke of, like, I saw this recently on Twitter, it's like, how do you build a renderer? You get a black screen first, then you get a colored triangle, a textured cube, and then you write everything else, you know. So to kind of fill in the gap, a couple of us at the studio took some open source projects and ported them over. Axel, who did the majority of Doom 2016 and quite a bit of Wolfenstein's Vulkan renderer, he made VK Quake because he's a big Quake 1 fan. It's based on the popular Quake Spasm mod. He released that around the same time as Doom 2016. I started on Doom 3 around the same time, but I didn't finish it for a year, and I'll explain that in just a second. But both of those are available to pull down now and take a look at. I also wrote a blog series about my efforts. There's a wonderful lady over at Binomial, Stephanie Hurlbert, who put out commissioned a Vulkan beginner tutorial challenge, and many people rose to the occasion. I threw my hat in the ring and wrote a 7-part series about it. I thought I'd get about 36 views because it's an old game. I'm not a graphics programmer. Instead, I got 30,000 views in the first month. It actually broke Squarespace's analytics report. You know, and I've averaged about 1,000 views every month after that. And I've had a lot of conversations with, especially with beginners that are going into university or about to come out of university. You know, and all in all, this kind of showed me it's like, despite the reticence kind of in the Beltway, there's considerable interest in Vulkan, a lot of excitement surrounding it, especially that are looking to add graphics to their skill set or are just like interested in it from a career perspective. So my personal reasons for doing the port was expanding my skill sets. You know, explicit APIs are kind of a nice inflection point in graphics right now because it's kind of a new paradigm. There's a lot of shifting around that has to happen. So if you've been looking to add it to your skill set, I'd say now's a good time. There's a lot of opportunity. That opportunity is not going to be around forever because everybody's catching up to speed. It's a good fit for me personally. It compiles in seconds instead of minutes, which is great. You know, and obviously familiar with id tech idioms, no red tape with open source, and fixed assets, so I didn't have to open Photoshop or a modeler or anything like that. And then the last part was just evangelizing, because we were early out, you know, and it was, you know, we kind of wanted to put out some examples of what it was like to go from a renowned legacy OpenGL renderer to modern day Vulkan. And we also had partners asking us how to make Vulkan more approachable. So here's the result. It'll look like Doom 3. I'm not sure why I didn't just shoot him through the glass he just broke. All right, that's it. So what did it take me to actually accomplish this? He's the reason it took a year, but I got some good pull requests out of him. a little over 700 commits. The Vulkan specific code was only about 5,000 lines. GLSL was about 3,000 lines, and that was trivial because the shader code was already written in GLSL. It took me, I estimate, about 4 full-time months to do the port, and that's with knowing nothing about Vulkan or really rendering altogether. Mostly worked from 10 p.m. to 3 a.m., and there may have been some Netflix involved. So lines of code is one of the major complaints. And as I said, the render I wrote was about 5,000 lines. Anybody who's written a renderer knows that most of your code's actually in the abstraction of how you're getting your data to the API. But it's interesting to note, lines of code's kind of an odd metric, but because it's used in this negative light, I wanted to point out that the OpenGL renderer that was present was about, actually 2,000 lines of code larger than the Vulkan one. And the delta for that was mainly just because it had amassed a bunch of debug tools that I just simply didn't implement. If I did, they would be about parity, but it's certainly not 10x in 2x, so. Breakdown of that code, the resource management of it, with the buffers, the images, the allocator, staging is all trivial. Most of it's consolidated into the pipeline management and the renderer itself. With pipelines, it's actually a lot of that code is just loading shader modules, pipeline selection, and filling out structs to submit to the API. And the renderer itself, half of that is just setup code. And that, I'll get to that in a bit. So what I want to do now is kind of take you all through a high-level whirlwind tour of kind of the port effort, and breaking it down into 5 different areas. Intuition, though, is something I wrote about quite a bit in the blog, and it's kind of something I wanted to point out. It's like, for people, as humans, we learn best by playing with things, and that's what makes graphics such a hard subject for a lot of people trying to get into it, is there's so much to play with, and there's so many variations that what you're learning you may not feel is necessarily right or correct. And the other cost is that you have a high resource overhead, so if you're not an artist and you're a programmer, it's like it's hard to get a data set that's worth working with. And so one way, and I challenge a lot of the beginners kind of approaching me from the blog series is to take something like RenderDoc, or another frame capture tool, but RenderDoc's really awesome, and just point it at a game, take a capture, look through all the draw calls, look at the state, look at the pipeline, look at your attachments. It's like that will give you more intuition than anything else. Like any tutorial, any coding tutorial you approach, it's like looking at the data will help you understand how you need to transform it and get it onto the screen. Not only, it's like a lot of people point at RenderDoc for being a great debug tool, but it's also just great in terms of exploring what's going on the graphics backend. A few areas that helped me, dynamic shadows were broken right away. Poor zombie is dragging around a shadow tail with him. There was some color channel issues right off the bat, and that stuck out immediately just looking at the texture attachments. And one day somebody reported that the Doom Marine had a concussion looking at glass. It was a very odd condition, but we got that fixed up right away. So the next step, this is actually, I think, one of the biggest hurdles that keeps people out of Vulkan, is they hit it, and there's a whole bunch of setup code. And they go, oh my gosh, if there's this much code up front, then what is it going to be like when I finally get to runtime? That's mainly because Vulkan likes to shift all the workload to the front, so when you're running, there's less overhead at runtime. There was a very kind of obscure diagram that was posted on Twitter recently about what it takes to render a single triangle. But in all that, there's actually a golden path that's going to suit most applications that have a single window, a single swap chain. You go through, and it's not, your mileage may vary, but this is what worked for me. Just create your instance where you're loading the loader. It's finding the driver for you, loading the extensions you've requested. From that, you'll create a surface that's bound to the window. You'll enumerate all the devices on the machine. Pick one, based on your selection mechanism that's going to be custom to you. From there, create a logical device and get queues. Most apps are going to have one logical device they submit all their commands to, and a set of queues for graphics present. If you're doing any computer transfer, you're also going to have that. From there, you'll create any pools that you might need, the command buffer pools, descriptor set pools, create any render passes you might need ahead of time, and then create the swap chain and get the images for that. And then for each of those, you'll simply just create the command buffer, or several command buffers if you're multi-threading, synchronization primitives for those, the frame buffers, and then allocate any data objects you may need per frame. In all of that, really, once you get through those things, the only thing that really stands out that's very Vulkan-esque is the render pass, and a lot of people have talked about that today. It can be complicated, you know, if you depending on your processes, but it wasn't for Doom 3. You know, there was one render pass with one subpass and 3 attachments. You know, depth, color, multi-sampling, and if multi-sampling was turned off, it was just 2. The only other thing I would do with the render pass is manually transition it to present source at the end, because the front end expected to be able to do a full copy for post-process, and that's something I want to refactor out at some point when I have time. So once you get over that hurdle, it's on to resource setup. So this is fairly trivial and straightforward for Doom. One large static geo buffer that was device local, uploaded everything to, and then double buffer dynamic geo that was host visible, mainly for particles and UI, a few things. Excuse me. And then you used UBOs for skinning and render parms. id buffer is really nice. It can treat a small range of a larger buffer as discrete to be able to be passed around. As far as images are concerned, there were only 12 formats I needed to support. They were all device local. All I had to do is track the image layout for the descriptor update, and all of those were really just transfer destination for the copy, and then I transferred them to shader read only. The nice thing about Doom is it's all level based, so I could do all of this at level load time while the load screen was up. Now we get into, this is one of the areas that I think a lot of people balk about, is the allocator's now been handed over to the developer. It's definitely kind of something that you have to dig into and figure out for yourself, but you don't necessarily have to. There are different approaches, especially if you're just doing simple scenes or if you're going through tutorial stuff. You know, for simple apps, just use the API directly. You know, you don't need to write a custom allocator. Just be conscious of your numbers. I think Tom pointed out the great gpuinfo.org site hosted by Sasha Willems. You know, it basically lists all the features, limitations, extensions supported by individual devices and drivers. The value I've highlighted here is max memory allocation count, and that's because, you know, and that's for this laptop right here, which has a 1080 in it. It's just 4K, and that's, you know, and that's where Vulkan expects you to sub-allocate. So if you're going to a small to medium app, you know, simple block allocator will suffice. You know, both for VK Quake and VK Doom 3, that's all we did. Just be cognizant of the rules in the spec. If you're going medium to large, you know, your memory access patterns are going to be, you know, maybe disparate, maybe not, but really depending on you, that's, you know, it's up to you to write something that fits you. As far as what I did, you know, I just did the typical create the buffer, get the memory requirements. I determined a memory usage flag, which was basically just, does it need to be host visible or not? I'd call into the allocator, and I'd get back a struct, which just had the pointer to the block ID, a unique identifier, device memory handle, offset size, and mapping if it was host visible. You know, at the end of the day, if you're just getting into Vulkan and you're doing small projects or, you know, medium projects and you're not like shipping something, don't shoot yourself in the face. You know, what I wrote was only 120 lines of header code, 600 lines of source code, and really all that's involved with this is just taking the memory bits from the requirements, associate that with a heap index, allocate a blockchain per heap, subdivide the block on allocation. If it runs out, allocate a new one on the chain, and then as you free, just merge that back, and if a block is completely free, just delete it. This is an example of what can happen if you aren't managing your memory correctly. The floor is not supposed to be iridescent. And then this was also mentioned earlier, but can't stress it enough. This is a single header file library. It's just drag and drop. I know Balder has said that he loves it, but as well, the Vulkan memory allocator that's in Doom 3, and you can switch it on. It's not on by default, but it just works. So if you don't want that overhead in terms of managing your own allocations, this is something that you can use. And I highly recommend it. Now I really want to talk about actually coupling to the idTech4 front end. So there's a long history with the OpenGL pedigree with id, and this is definitely apparent in idTech4. John started working on the render in early 2000s, and the BFG team kind of modernized it a bit, and it's still present and running today. It had grown roots. You know, it was present in about 18 files, not bad, but still leaky. There was state that had been externed everywhere. The PS3 360 code, obviously, we couldn't open source that, and those had gone down completely different implementation paths altogether. But I didn't want to start fresh. I actually wanted to keep things working side by side so I could see where the rub was between the two APIs and the paradigm shift. And so a large part of the effort was actually just putting the beast kind of back in its cage and getting an abstraction that worked for both APIs. In the end, I was able to sequester the code or refactor it back into just 8 files. So the main thing with the front end is that you know, it's designed to change state immediately through commands like GL state, select texture, bind texture, clear. It's just changing state in the middle of a draw call depending on different conditionals. And this is where a lot of the state tracking actually comes in, because Vulkan doesn't have any of that. It doesn't, you know, it would prefer that you save it for the appropriate time, such as just at descriptor set updates, pipeline selection or creation. Thankfully, the IDTech 4 had the idea of GLS bits, which was basically just the renderer state in bit flags that were passed around. It wouldn't save the data off because the OpenGL renderer would just submit that to the driver to hold on to, but it would at least have an idea of what state it had submitted. An example of this is in the GL state call is 210 lines of code, and so it's calling into all these GL calls to, you know, change the depth, change the stencil, all sorts of things. And in Vulkan, all I did was just save that out and use it later. So now we'll actually talk about the draw call and see where that state's being used. So as far as the rendering is concerned, there were only really 2 passes. Surface-based drawing, most of id games up until Tech 6 were surface-based, which is basically just contiguous triangle calls, like you see to the left. And there was basically the main lighting pass and the stencil shadow pass, and there was also kind of a trivial post-process pass. The steps involved won't surprise anybody that's done any kind of rendering. It was really just find the offset into the global index vertex buffer. If the shader needed to skin, I would just cache off the joint handle for that. The new bit was committing the state that Vulkan needed before the draw call, and then bind index, bind vertex, draw, and that was basically it. So as far as what was happening inside the commit current, what would happen is inside a draw call, the back end was, the front end would say, you know, bind program at this index. And then what would happen on commit current is it would use that index to retrieve a render prog, which had the shader, housed the shader modules, and a list of viable pipelines for those shaders. It would look them up based on the GLS bits that had been set and saved off. And if a candidate pipeline didn't exist, it would just create it. There were no noticeable perf hits with Doom 3. Things settled pretty quickly, so I didn't bother with the pipeline cache, although that would have been trivial to implement. You know, overall, the back end at 1080 with multi-sampling on, it runs in about 500 microseconds, so perf wasn't necessarily a concern. With the descriptor sets, I just brute forced that. It was still quite fast, as I mentioned. You know, so as the state was coming through, I'd allocate the descriptor set from the pool, update that with the incoming UBO and textures, bind that, and then bind the pipeline, and then it would just exit out and do the draw. So all in all, there were only 28 built-in shaders, plus some change at level load time, but not much. Under 100 pipelines on average throughout the entire process. You know, and so that really just allowed me to create all of that up front. You know, on startup, I could just create all the built-in shaders, their descriptor set layouts. I knew what my vertex descriptions were ahead of time. There were only 3. Create the descriptor pools for each frame, and then pre-allocate the UBOs for the render parms. And that was it. You know, the complication really just came from trying to marry the 2 different APIs and their expectations with kind of an abstraction, and I think that's where a lot of kind of the difficult part of people's complaints come from, is because they have a tech stack where they're used to a driver that will take state at any time, as opposed to Vulkan, where it educates you on when best to submit your information in your state and correlation between that state. And so, you know, before closing and going to our panel, one last thing I want to talk about is kind of that aspect of it. You know, with the paradigm shift that's happened, there's really there's the 2 paradigms, you know, with different workloads and overhead at runtime for processes. So there's an intermediate one that I like to call explicit light, which I think is where a lot of people land early with their Vulkan ports. But essentially a legacy process, there's little overhead to getting to where you're rendering, and then there's a consistent overhead if you're doing things right with your process. And then as people start switching to Vulkan, they pay that upfront cost that I mentioned earlier, but then because they have a stateful front end, stateful branchy front end, they're still paying the overall overhead cost. But the nice thing about that is it's all about iteration, because as you kind of get it in, it'll start informing what state that you can move up front further towards initialization time, to where when you've gotten kind of a fully explicit renderer, you're paying all the cost up front. You may have a little bit of settlement period over the first few frames, and then you have considerably less overhead as the process runs. I would have to say that my port kind of landed in between the two, mainly just because it was a learning experience for me. When Axel did Doom 2016, we definitely saw some benefits early on from the Vulkan port, but because it was still tied to an OpenGL renderer front end that we had shipped, we still weren't seeing all the benefits. And then hopefully they'll be able to talk about this in the future, but because we were Vulkan explicitly with Wolfenstein 2, we saw even more benefits from that. And so that's kind of the evolution of people transitioning their tech stacks. I would say if you don't have a tech stack and you're writing something fresh, it's like you can just start up there. You don't even have to try to accommodate anything legacy. And that's it. Special thanks to, did anybody read the blog series? Oh, thank you. I love you all. And Axel and Tiago for their advice, and Stephanie for encouraging me to write the blog series. Special thanks to John, really, for having the foresight to open source projects. I think those keep paying dividends. And also the original Doom 3 team and the BFG team. There's two other ID alumni that are no longer with us, John Paul and Stephen Seraphin. They both made major contributions to ID Tech over the years. JP passed away last year, and Stephen passed away a few years ago, but their impact's still being felt at the studio and in the games that we ship and that people play. So many thanks to them all. Panel time?
Panel time.
Panel time.
Cool. Thank you, Dustin, for an awesome presentation, and the blog series, it really is so helpful, no matter what level of experience you have with Vulkan. My name is Alon Orbach. My one remit here, as we decided this session, was not to talk a lot. That's the one condition. So I work for Samsung with Fred and Ine, who were speaking earlier. But any questions for Samsung, I'm afraid I can't answer, which is fine with me. So can we get the panelists up and let's get going. So if you can start coming up with questions, that's the mic, and let's just. And where's our roving mic? Is the question. Where is the roving mic? It was around here. So meanwhile, I'll do the other bits which I'm going to do at the end, whilst we find our roving mic. We want your feedback about today's sessions. So as well as doing the GDC feedback, which will give you the chance to win stuff, we do have a bit more explicit feedback we want. As Tom in the opening said, we really are trying to be more open in Kronos on how we do things in Vulkan. So we want to know, how did you find today's sessions? What topics you thought were well covered? What do you think we should cover in the future? And also, there's one event we're planning, which I'm particularly keen to find out. Lots of lovely people in Montreal are willing to travel to Montreal on April 30th. We've got a day of Vulkan planned, so do give us your thoughts there. So without further ado, I've stalled enough and we have a mic. So to start us off, just one question with a brief answer. For developers getting started with Vulkan now, if you had to give one tip, what would it be? If you want to kick us off.
I have a. Assume this on. Somebody said something to me recently, and this is really low level. But I have a tendency to just go really deep on everything, and I was bugging Tobias about synchronization and scheduling at the GPU level. And he said to me, you know, on some driver implementation, scheduling work is very similar to how your compiler schedules instructions for execution on the CPU. And I started down this weird path of reading all these like ILP books. And one day it snapped at me that I finally understood synchronization. So if you're planning to go really deep with Vulkan, and sorry, it's not a starter question, but if you really want to understand that, you really have to take the word pipeline in Vulkan literally. It's an instruction pipeline. And when you begin to take that literally, it really helps you understand how the synchronization comes together.
Arseny.
In 2 words, especially after what Kai said, don't despair. So my serious advice, I guess, if you're starting to develop Vulkan, I think try to find a healthy balance between using all of these shiny new concepts that you never heard of before and not doing that and doing something that may not be recommended by some tutorials but could be easier for you to understand, because totally agree with Dustin, it's all about iteration. Like if vendors tell you use subpasses and render passes, etc., and you're writing your first or second Vulkan app, just don't if it makes it harder for you to understand what's going on.
Yeah, I'll echo both of those. Like, you know, with Doom 3, I mean, it's an old game, but it's far more substantive than, you know, a lot of your beginner tutorials are, and that's why we put it out there. You know, and it didn't use a lot of, you know, you notice I didn't talk about synchronization or anything like that, and that's because there was very little of it. Doom 3 was inherently single-threaded, and that's fine because the performance didn't require it to go multi-threaded. But you can get in and you can learn because it's only a few steps up to learn the new, like, Vulcanness that's there. I'll also echo what Hai said is, like, I think what hit home for me is, like, in OpenGL, it just accepted state at any time because the driver's like, oh, I'll just hang on to that and submit it because I know when I need to submit that to the hardware. You know, but with Vulkan, it's like you're expected to hold on to that, which seems like more overhead. But I found that more intuitive because it's like now I understood what was exactly happening to my data, where it was, what state it was in, you know, and when I'm supposed to actually give that over to the hardware.
Matthias, so.
Yes, so my advice would be just to read the spec, because there is...
End to end.
Not necessarily end to end, but I have been supervising a couple of students in the last 1.5 years who have been like just beginner graphics people, and they was like, how do I do something in Vulkan? And it's like, well, did you try reading the spec? And they were like, no. And I found out you can actually read it, right? So if you only go for the create parts and you don't go for the delete parts, you can actually get your first window up by just reading it, and you shouldn't be afraid of reading the spec.
I'll echo that. Actually, I'd say, you know, Cronus has done a really good job with making the spec readable and digestible overall, and especially even just the header. You can just look at the header and see everything that's available to you. So consolidating all this stuff into one place has actually been really beneficial, I think.
Well, if we can get questionnaires ready. And apologies for not doing a proper introduction during the panic. I think we kind of have a flow between the devs that have to face Vulkan day-to-day and dev techs that have to help our developers along, and myself who has to figure out the balance between helping dev techs and explaining the standard. And it's great fun to balance that along. Are there really no questions? I've also got some planted questions, so I'm shocked there's none already. Go ahead, Hai.
So, Dustin, in your development process, did you use any tools like RenderDoc or any like profilers to measure your speed or debug your shader issues?
I mean, I use RenderDoc extensively. Oh, yeah, sorry. I use RenderDoc extensively. You know, and that's why I dedicated several slides to it. And, you know, if you follow Balder on Twitter, you notice he threw a celebration party for, what was it, 1.0? All right. It was a very sad party. Buy that man a beer. Get this man drunk tonight.
We will definitely.
Go ahead and please introduce yourself.
Hi, so my name is Sajid Farooq. I'm a professor of graphics at Champlain College. So we at Champlain College were one of the earliest to start teaching Vulkan in an official capacity about 18 months ago as part of our advanced real-time graphics. I just wanted to first affirm a couple of things. So it is, yes, it is very front-heavy, and especially when it comes to students, the problem is that the hardest part is the front. It is the first steps. And with an API like Vulkan, you are trying to do everything, setting it up and all of that. A lot of new concepts have to be taught from day one. So we spent maybe in an advanced real-time graphics class, like 3 weeks just teaching the beginning of it, just getting to drawing something on the screen, a triangle. And then we moved on to some interesting things like the ray tracing in a weekend or whatever, right? Yeah. So that is one thing that I wanted to affirm. Now, I'm not an expert on Vulkan, even though I teach it, and that's how most professors are. But but having said that, so I don't really know whether it is possible. But my question is it possible to have some sort of sensible defaults when it comes to Vulkan, so that it's not so heavy to set it up, and so that you can have our students, and again, I know that there are a lot of APIs out there. The problem is with the other things that are on top is that they're not standard. So I'm kind of saying if we can have something which is standard.
So I mean, I'm a downstream consumer, but at least from my perspective, and I know a lot of people are talking about this, and Arseny even mentioned this earlier today after his talk. It's like, I think there is room for kind of drag and drop black boxes for certain things. Like, that's why I mentioned the memory allocator. It's like, okay, if you don't want to eat that overhead just getting into it, it's like, here's something that works for you. And so, you know, having something that does like the device selection and queue retrieval for you, and maybe just a few lines of code, and having that as a nice setup for like a single windowed app, I think that's kind of a great solution for who wants it next. You want it? Okay. Do you want it?
I'm glad you're asking this, because before I was sitting up here, I was heckling Kronos about the exact same thing at these kinds of events. One of the best sources for that is to scour Sasha Williams samples and pull out the values in there. I'm sorry, it's not like a sensible default, but if you want to collect them until somebody puts together a source for one, that's a good place, because I found myself into some really sticky situations where I needed something to just come up on the screen, and that's where I always fall back to.
Yeah, and one thing on the sensible defaults, like if D311 has taught us anything, is like we can't set up sensible defaults, so we have tried really hard, and I found it to be very valuable for like a student if he, like, how does this write discard work? Oh, and there's a rename buffer, and like how big should I make it? And it's like, well, you can't set it because D3 does it under the hood, and now it's probably suddenly exposed to you, so that you can ask, like, you can start a conversation with those people and say, like, well, how would you actually set this default, right? And then they have a deeper understanding of the whole thing, and I think that's more valuable than just having like this default implementation which has like everything set up incorrectly. So that's my take on it.
So I just have one question for the panel, and also wouldn't mind doing a show of hands here. Marcus Tavernrath and the work has been done on Vulcan Hpp to kind of look at a slightly less verbose access to Vulkan. Would you recommend it, or why do you not think there isn't more uptake and preference to use the C bindings rather than the C++?
I have to recommend it because Marcus forced me to. I pushed him to add the namespace stuff, and so I think it depends on what kind of workflow you have. For certain people, it does make sense to have VKHPP, because it does initialize certain things to reasonably sensible values. My preference for the C flow is that because of games and working with games, I prefer to see the low-level code, and I think that's what a lot of people share that opinion.
So we do not use Vulcan Hpp, and since nobody asked me to recommend Vulcan Hpp, I won't. I think from our side, I think tutorials are awesome. Libraries that help you deal with parts of your initialization flow are awesome. Vulcan Hpp, in my specific opinion, isn't necessarily worthwhile. Like, the big problems are half of the tutorials will not use it, so you're Googling for a thing, it's not there. Spec does not use it. The header is very large, etc. So I feel like there is more value in having a library that sets up the device for you using the completely incorrect defaults, but it doesn't matter, it's open source, right? So you can look at what it's doing and change it if you need to, as opposed to redefining the entire API in C++.
You know, one thing with the setup though is, like, once you get over that hurdle, you don't need to cross that every time. You know, so if you can write something, you know, that really works for like, basically, if you're just writing games, it's like that will work for you for basically most of the games that you write, and you can copy that code around. You don't have to cross that threshold every single time, so you're only paying that cost once. And the nice thing is that you can understand it up front. With the with the C++ stuff, I definitely prefer just the cleanliness of the C API and handle-based you know, submission. And mainly, I think Vulkan does a really good job of kind of like telling you what it needs with every API call, and I think that's what's made it more intuitive, especially for me getting into it, and I think for other people as well.
Yeah, so adding to Dustin's point, I mean, the moment I saw the Vulkan spec, I invested heavily in keyboard manufacturers. But it turns, unfortunately, out that this typing effort, like this typing overhead, many people have been afraid of, it's very minimal, right? Because it's like you have this struct you need to fill out, but it's like, if you're a beginner in programming and you're filling out your VK buffer struct in like 27 places over your code base, you need to revisit some life choices along the way, because that's not how programming works. And it turns out in the end, it's like the overhead is not that big, and I really didn't get like much like return on investment on my stock.
Yeah, and that was why I took a couple slides to kind of point that out, is like, when you're filling out these structs, it feels like you are, you know, writing a lot more code, but you're not. You know, at the end of the day, you're not. It's because, you know, you have all your data flow into one point where you're actually doing the submission or the state tracking. And expanding up from something like what I wrote isn't going to add a whole lot of code to your application.
Go ahead. Thank you for your patience.
Yeah.
DJ Kehoe from NGIT, also a professor. So I teach game programming courses, and my question is, how ubiquitous are Vulkan jobs right now? Because I'm in the process now of refreshing some of our software, some of our tutorials for the classes, and I'm still debating whether I want to focus on the OpenGL 3.4 spec or Vulkan, because what's going to be the best payout for my students?
So I have half a dozen Vulkan openings, and I have 0 OpenGL or D3.11 openings right now. So if you have 10 people with Vulkan experience, I can hire them all.
We'll talk.
I can speak that too. We actually now, I mean, we're fully Vulkan for all PC. You know, this is where, you know, high-end gaming is going, and it's also just where technology, graphics technology in general is heading. We actually hired somebody recently because, you know, they were fresh out of a master's degree, and we were like, you know, he showed us what he could do, and we just kind of challenged him. It's like, have you learned Vulkan? And he's like, no. And it's like, well, we'll go take a look. He came back a few months later. He had written a renderer, and we hired him, you know, because he showed initiative on that.
I mean, just to add on this, I had 2 students recently graduating who both did a Vulkan project, and they are both like, well, they could pick basically the ISV they can work with.
So from our perspective, we do not have a job description of a Vulkan graphics programmer. However, what we find in general is people who are interested in Vulkan and people who are willing to go and ask the questions and make a render, but then also ask the questions of why is this done a certain way? Like, what is actually going on here? Why does the driver need to create a PSO and has to have the vertex shader, the fragment shader, the blend state, etc.? Like, why? And if you find answers to these questions, your depth of knowledge as a graphics engineer increases, and these are people who would like to hire. So I don't think Vulkan as a technology, as like a specific technology, is part of this. It's just the amount of knowledge that you could get by asking the right questions about this that's beneficial here for us.
Part of my job is to try to find people who know about Vulkan, and it's been very hard. So please encourage your students to learn Vulkan, use Vulkan, love Vulkan.
Higher left, right to left, right.
Yeah, and I think it would be remiss from my managers if I don't mention our openings as well. Yeah. Galaxy, game dev, we're hiring, game dev at Samsung.com. Any other questions? I know there's people willing. Come on.
Well, one thing I'll mention
If not,
on the hires too, and getting more people with skills that know it, is you know, just expanding the technology. It's still really early. The soil is fertile, and we just need more developers in the pool to kind of help push the technology forward. And that's, you know, part of the reason I even came out.
Great. So whilst people are being shy, please don't be shy. I'm going to ask, one of the hot topics has been around Vulkan in terms of cross-platform and how much benefit you find of having one API that's targeting both mobile and desktop platforms.
So we did Linux dedicated servers for Dune 2016, and a few of us who are Linux heads in the studio are just like, let's take it the full way. And all we had to do was change the surface that we were creating for the Linux version of it, and it just ran. Like out of the box, performance was equivalent. And so it's like having a smaller driver actually helps a lot there, I feel.
So for us, the cross-platform aspects have been really good. Modulo the stability issues that I covered, we pretty much have a single code base. There is like a couple of small differences, but we don't even have to have them. It's just the performance is a bit better if you do like a certain thing here because you know the memory is unified. But otherwise, the Vulkan backend for us is probably the most cross-platform between mobile and desktop. It's strangely enough, it's slightly better than Metal because Metal on iOS allows you to just assume it's unified memory. So if you start on iOS and then you go to Mac, on Mac you suddenly realize the memory management changes a bit, etc. And Vulkan forces you to do like pretty much everything up front, but then you go to another platform and it pretty much just works.
Yeah. Hi loves cross-platform. Then
I do. I was one of the first promoters of Alon's work on the WSI. Porting demos to Linux took about 3 hours because how flexible WSI was. But if you were a recreational graphics programmers where you want to do ray tracing in a weekend or Vulkan in a weekend, and you want to see your stuff run on Windows or Linux, especially if you use something like GLFW, it's kind of instant. There's not a whole lot of work. You just rebuild, and Linux, and it generally works, assuming you don't have any platform-specific code.
go ahead.
I heard talk about a open source platform layer that calls into Metal. Have you guys had any experience with that?
Yeah, where is?
Looking for the Valve folk. Oh, right at the back. Come up. Or shout loudly. So this is the Vulcan Portability Initiative and Molten VK. But rather than me talk about it, given how much my employer loves iOS, I'll pass you to Dan.
I'll take that one. Yeah. Which one do you want?
Basically, we have this initiative within Kronos called the Portability Initiative, and part of that is Valve has been working very closely with the company Brenwell Workshop to open source Molten VK, which is a layered implementation of Vulkan on top of Metal. And we've also ported our engine, which has a Vulkan renderer, source 2, to run on top of it. And I gave a talk earlier today. We're getting a lot better performance with our Metal renderer on, our Vulkan renderer running on Molten VK than OpenGL on macOS. So it's up on GitHub. My slides should be, I think, on the Kronos site, which has links to where you can get Molten VK. And there's a macOS SDK as well from LunarG on Lunar Exchange, which contains Molten VK and the validation layers and loader. I think it was public at the end of February, yeah, so about 3 weeks ago.
So all open sourced.
So we do not use the Molten VK, but I do want to mention that as part of Molten VK, what we did get is MSL support in SPRV Cross, and we recently started shipping our metal shaders compiled via Vulkan bytecodes. We compile HLSL to SPRV via GLSlang, and then SPRV to MSL via SPRV Cross. And this works today. So that has been great.
Go ahead, do introduce yourself.
Is this thing on?
Yeah.
Cool. Hi. Yeah. Kojo. I work at Google, and I'm really excited to start getting into graphics programming and learning graphics programming. So thank you guys for this talk. It's been really good. And my question is, oh hey, I'm louder now. So my question is like, someone who's new and who's like picking up stuff and figuring out where do you start. And I'm kind of wondering like where is best to invest my time. So you guys have given a lot of information about why Vulkan is great. And before I was also really looking into like OpenGL. And so I'm sort of wondering like, if I'm considering like learning Vulkan versus OpenGL or a different graphics language, which is going to give me a good, introductory into like general graphics concepts that'll port to a lot of things versus like writing thousands of lines of Vulkan code up the front.
Yeah.
Which sounds like a lot of work just for Vulkan.
And that's kind of why I talked about like, to my slides about RenderDoc and Hai's point about pipelines. It's like understanding the pipeline intuitively, like that's the best place to start. Mm-hmm. And you really get that though from like the hard part about it, like I said, is learning is you have to have a lot of data to put through it. It's basically like a DSP, so it's like it's doing all these manipulations. You have multiple data sources, and so that's hard to get those handholds of intuition on. And so if you have something like a frame capture where you can just basically take RenderDoc, download it, it's free, take a capture of a game frame, and then just step through all the calls. You'll see it. You'll see a texture, basically the frame buffer change on each draw call. You can see the state that's set for all of it. You can see the textures that are used. And so that will give you, I feel, a really good intuition of how exactly what you're seeing on screen is built up as you see that layered. I have a few galleries on my blog where I went through that, and you can just see it. It's like, okay, oh, there's the daemon that popped in. Okay, there's the sink that popped in. And so we're very visual creatures, and a lot of us learn visually and by playing with things. And so if you have data with the frame capture, and you're looking at the pipeline stages and how that data is transformed, that's going to be, I think, the best thing over a book, over code, over anything else for you. And the barrier to entry is really in that you, in and of yourself at home, cannot build a full game, on your own without a lot of effort. And so that's why these tools are great.
Yeah, so if you program OpenGL and you try to program a GPU, right? That's not really OpenGL was designed back in the days, and that's not mapping to the hardware at all, right? And you pretend, and if anything breaks, you're just like, this black box has like 27,000 state knobs and something is not working. And it's very easy to get frustrated with like OpenGL or D311 just because you don't know what's happening. And in Vulkan, if it's breaking, it's usually like, okay, I'm setting something wrong, or this is like the state I'm missing. And it gives you both a better understanding of the hardware, because the OpenGL doesn't teach you anything about the hardware, right? There's stuff in OpenGL like line stipple with differing and whatnot. And sorry for opening old wounds here. And there's no hardware which ever did this, probably. And at the same time, in Vulkan, there's nothing which is not in the hardware. Like, we don't emulate anything in software. So that's giving you both, you learn both graphics and the hardware, right?
Hi, and then our last question.
I also work at Google, and if you want to talk about graphics, please email me. But and just aside from just the learning parts of it, if you're going to communicate with the community, it's helpful to know something like Vulkan or a modern explicit render, because all the terminology that you're going to run into is not going to be mapped back to OpenGL easily, or even DX11 in some cases. So knowing the concepts and the ideas of what's happening, you'll understand what's happening going forward with modern graphics.
So one big issue that I find with OpenGL is it seems deceptively simple. If you want to write an app that draws a bunch of triangles, even if you want to use shaders or whatnot, like buffers, it seems very simple. But the actual reality is, even bypassing, forgetting about the fact that the driver is lying to you and not doing what you think it's doing, there is many layers of the APIs that are sort of deprecated, but you have to use them in some cases. Like you look at your OpenGL code and then you go, oh, how do you do this in OpenGL 4 or 5? Oh, there's like direct state access. All of this old stuff that I was using is like you should not be doing this anymore. Or you go back to GLES 3 or God forbid 2 and like, oh my God, half of my API isn't there and my shader syntax is different. What do I do? So with OpenGL, it's like a bit of a trap where the initial learning curve, I think, is better, but it's like it's like a swamp, right? You go there and then you don't realize that you're stuck up until you're drowning.
No. Before the mic,
GL begin GL quads, right?
yeah. Before I have no way to cut the mic off, but I think to explain, OpenGL does still have a purpose, and especially OpenGLES as shipping in billions of devices. I think the issue is, as a training API, it's not giving you the right indication of what the GPU is actually doing. But for many people that don't need to squeeze every single bit of performance out of a GPU, OpenGLES is a reliable cross-platform API that everyone loves. Right. Final question.
Thank you. Well, I just wanted to add one last thing real quick. A lot of the talks, focused at least in part on the validation layers and what it was giving back. All that's really quite good now, especially for somebody writing medium to simple applications. Where the issues or the cracks where it's showing are kind of like, people that are shipping big projects on it and doing a lot of interesting things that the technology just hasn't faced yet. But as far as you learning, it's like if you turn on the validation layers, that's going to give you a lot of information about what you're doing wrong and what is expected of you, so that's also going to educate you. All right.
Go ahead.
My name is Charles. So we know.
Hey, Charles.
Hi. I know we are at GDC, but for applications that are not games, like software, like normal software, where we don't have a rendering loop with all the resources created in a single spot, where we have a legacy GL where GL was managing the lifetime of our objects. So how do you guys would suggest we add Vulkan and manage our lifetimes? Is it having a ref count for each object, or how would you do it?
I would probably throw away the OpenGL thing and start from scratch designing it for modern GPUs, because the OpenGL manages lifetime dynamically and so on. That's not how you efficiently drive the hardware at all. Okay. So I would try to get hold of what is my data, when is my data visible, and then map this onto the GPU, because that's how it actually works. I wouldn't try to gradually retrofit memory management from OpenGL to Vulkan.
Just to clarify, are you asking from a software design perspective, or are you asking from a usage perspective on Vulkan?
Mostly usage.
Okay.
It's a big code base. I'm probably rewriting it over with all the data would be a big job.
I think there's we can talk about this offline, but there's for bigger level applications like something like Maya or something like that. There's definitely a management layer that probably needs to be applied on top of that, because you're going to have to recreate a lot of things that particular interface is used to. To Dustin's point earlier, that something like Maya has a more brutal interface when you're trying to fit that particular side of the data that you're trying to get from the API side into the graphics API. And admittedly, OpenGL is probably a little more friendly for that, but it is entirely possible to do with Vulkan. And come find me afterwards. I'll come find you and we'll talk more about it.
Thanks.
And very last question here, I have to say, we're out of time, but here's my colleague at work, so I have to be brief.
Hello, my name is Francisco. I work at Samsung. So I was basically gonna give my perspective, because I've been working with Vulkan, basically porting an engine that was written in Glass 2. So I can add actually to the question that was just asked. The thing that was mainly an issue, like Dustin mentioned, is creating a layer that can abstract between the two APIs. That's where most of the effort goes. And really starting to deal with the issues that you can ignore in Glass, like memory management, in particular in Glass 2 and synchronization, because the API is so simplified, which is good if you're learning or if you're targeting very cross-platform devices. But when you're trying to abstract things between Glass 2 and Vulkan, it's really, you have to do all the work that Vulkan requires. And I think that there's a scope to have better APIs that would learn, that would help people that are learning or creating applications from scratch for Vulkan that don't necessarily want to learn all the details of synchronization, memory management, low-level APIs. They just want to do graphics.
All right, I mean, that's where things like the Vulkan memory allocator come in,
Yeah,
right?
sure. Yeah, that's great.
And you as the community, if you can make the Vulkan synchronization layer, then be my guest. I will print T-shirts like Vulkan synchronization layer and your name on it if you do it.
Cool. Thank you very much. Firstly, thank you to our panelists. I think it's been a fantastic discussion. Thank you to all the working group members for all your effort today, the GDC staff, and mainly thank you all of you attending, especially those of you who sat through the entire afternoon here with us. We really would value your feedback on how today went and also future sessions. There's still more stuff. There's a bag of badges. There's T-shirts. Please grab them, and please do help our lovely GDC staff by clearing up your stuff as we leave the room. Thanks again, and see you next year.